my dear students, how are you all? I hope you all are fine. Today we are going to start with the part 2 section of periodic classification of elements. If you haven't seen part 1, go and watch that part 1 section, because there we have discussed about the discoveries done by very renowned scientists where they assign the elements according to their periodic theories. In the periodic table, we have discussed about the John Dalton, John Dobrunner, who has given the triads of elements, and then we have discussed about the John Newlands. Then we have discussed about the Dmitry Mendeleev, whose periodic theories becomes the foundation or the basics to assign the elements in the periodic table. And we have also studied about the Henry Moseley, who has worked on certain elements and has specified atomic number is the one from where we are going to assign the elements in the periodic table. That's it. In the part 1 we have done all these discoveries. Now in this part 2 of periodic classification, which is considered as the greatest tool in learning the chemistry, we are going to learn more about it. First thing first, we have already studied that what is periodic table. We have studied that periodic table is a sort of map in which assign the positioning of the elements in the periodic table. Now you have to imagine that it is a classroom and there are 118 elements present inside the periodic table. Okay, so it contains atomic mass, atomic number, and chemical symbol associated with a known element. As today there are 118 elements in the periodic table. So we already know the different chemical symbols of certain elements, like hydrogen is represented by H, helium by He, beryllium by Be, like this. In order to learn the periodic table, or in order to understand the periodic table, I would suggest you all to learn at least 1 to 20 elements with their chemical formulas and with their symbols. Alright. So when we imagine the periodic table as the classroom, we got the structure of periodic table. As in the classroom, we study that the students are arranged in a rows and the columns. Similarly, in the periodic table, the elements are being arranged on the basis of their atomic number, which is the number of protons in atom's nucleus. Now, there are periods and groups in the periodic table where we term as horizontal lines as the periods which are running from left to right, and then top to bottom, that are vertical rows, which we termed as groups in the periodic table. So horizontal rows are called periods, indicating the number of electron shells, and vertical columns are called groups, where elements share the similar chemical properties due to having the same number of electrons in their outermost shell. If you get confused between rows and columns, you easily understand it by top to bottom elements sequence is known as groups, and the elements which are running from left to right are known as periods. Okay, like this you can easily understand the periodic table. Now a row is called a period. The horizontal row is called a period which is running from left to right. Each element's atomic number increases as you move along the period. So atomic number increases as you move along the period. Now the periodic table, we need to see a period is a row of the table. Rows run horizontally. There are 7 periods in the modern periodic table. This you need to consider. How many periods in the periodic table? There are 7. As you can see on the screen as well, starting from, we are going from left to right. Okay, left to right is the horizontal row, and that is considered as a period. This is the number 1 period, which is going like this. Number 2nd period, which is going like this. 3rd, 4th, 5th, 6th, and 7th. So these are the 7 periods present in the periodic table. Alright, now the columns are known as the groups, which are running from top to bottom, right? And can you guess how many groups are present inside the periodic table? When we count them, there are 18 groups in the periodic table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. You are going to learn like this always, groups running from top to bottom. These are the columns and groups in the periodic table. Okay. So now we are going to see what are these two lines which are present below the periodic table. Actually, they are running from horizontally. They are running horizontally. These are the horizontal rows and the part of periods only. They are known as lengthenites and actinites, but their positions are not being assigned yet inside the periodic table. That's why they are present below the periodic table, but they are the part of periods only. Now, why they are named as lengthenites and actinites? Because as you can see, their first element here is lengthenite and here is actinite. That is why lengthenites and actinites present below the periodic table. They are the part of periods only. Now, there are certain more elements which are present inside the periodic table where we learn them as the part of the periods and the part of the groups. There are metals and non-metals in the periodic tables, which are, you can find the metals on the left and the middle part of the periodic table. Generally, the metals are present at the left part and sometimes in the middle part of the periodic table. They are good at conducting electricity and heat, and they can be bent or shaped easily. Ductility, lustrous, malleable, they all are considered under these properties. Non-metals are present on the extreme right side of the periodic table. They do not conduct electricity and they can be solid, liquid or gases at the room temperature. And they are present at the extreme right of the periodic table. Remember this. We have already studied about the metals. Now you can see the metals on the left hand side. These are considered as the metals, all the green thing. In the middle also, these are metals. These are the metals. Now when you go extreme right are considered as non-metal, as you can see in the lavender color or the purple color. Now hydrogen is also considered as a non-metal because, as I have already told you, non-metals can be liquid, can be gas. Okay, so metals are the solids one, non-liquids can be liquid or gases. So hydrogen is considered as a gas. That's why we are considering hydrogen as a non-metal. So to your extreme right, these are non-metal, and to the left hand side, these are what? Metals. Okay. To think of the elements which are present in the yellow color. What are they now? What are they? So these are the elements which are known as metalloids. Metalloids, the properties of metalloids can be similar as that of metals and non-metals. They appear to be more like non-metals, but some conduct electricity. These so-called metalloids are the semiconductors, are useful in electrical devices. Okay, so in your inverters, these elements are being used as the semiconductors, which helps in conducting the electricity. Their positioning is close to non-metals, but they show some properties of metals as well. So they are the conducting elements and they are the metalloids. Okay. Now there are certain key areas which you need to remember when you study in the periodic table. We have already studied that there are the horizontal rows and there are 7 which we term them as the periods, and then there are the 18 groups which are the columns present in the periodic table. Apart from periods and the columns, apart from the periods and groups, there are certain key areas which you need to understand. There are group 1, 7 and 0 elements, which generally are the major areas of the periodic table. The group 1 elements are called the alkali metals. Now why they are called as alkali metals? Because these metals can dissolve in water easily. So by dissolving in water, they form the hydroxide ions and they are basic in nature. That means these elements can form bases when dissolved in water because they result in the formation of hydroxide ions. Now then comes the group 7 elements, which are halogens. So chlorine, bromine, fluorine, iodines come under the halogens. They are the highly reactive elements and are present at the group 7. Group 7 is generally, it's group 17 only, but since the valence electron is 7 in these elements, that is why they are also referred as group 7 elements. Transition metals, the elements which between groups 2 and 3 are the transition metals. You can see these metals which are present in between the metals and non-metals, like the middle metals are the transition metals. Why they are known as transition metals? Because they show the properties of both metals and non-metals. And the common example is iron, which works as a ferromagnetism, right? They are helpful for generating the magnetic field, right? Group 0. Now why they are considering as group 0? So is there any group 0 element? We have studied any group 0? No. But group 18 is considered as group 0 elements. Why they are considered group 0 elements? Because they are stable in nature and they have all the electrons present in their electronic shell. Their shells are complete. They are stabilized elements. They can't react anymore. They are inert gases. That is why they are known as noble gases as well. And they comes under group 0 elements, or you can say it group 18. Group 0 because the electronic configuration is being fulfilled. We will start with group 1 alkali metals now. Group 1 alkali metals, that the metals which can dissolve in water, they can form hydroxide ions, and they can result in the formation of bases. Group 1 elements known as alkali metals including lithium, sodium and potassium. They are highly reactive, especially with water, and have one electron in their outermost shell. This I have already told you. Then the transition metals, lanthanides, actinides, they are known for forming the colored compounds having multiple oxidation states and being good conductors of heat and electricity. As I have already told you that transition metals are the one which shows both the properties of metals and non-metals. Metals as they show the conducting electricity property, and the colored element shows that they can show the non-metals properties as well. And the most common example of non-metal or the transition metals is the iron. Okay, iron is the ferromagnetic property. It shows the ferromagnetism property. That means it shows the magnetic field. Then comes the halogens, which are present extreme right. Group 7 elements or the group 17 elements are called the halogens, include fluorine, chlorine and bromine. They are reactive nonmetals with 7 electrons in the outermost shell and form salts when they react with metals. Okay, so for example, Na is the metal. When we react sodium with the chlorine, which is the halogen, it will give the formation of sodium chloride. Okay. In the same way, when we talk about the alkali metals, the metals which get easily dissolved inside the water and gives the formation of hydroxide ions, as you can see, sodium hydroxide, that is base generally. Okay. Now we will talk about the noble gases, which we have already studied that noble gases are found in group 0 or group 18 on the far side of the periodic table. Some elements found there are helium, neon and radon. Noble gases are very unreactive, or you can say they are inert or stable gases, or also the noble gases, because they have no electrons in their outermost shell. They glow bright colors when electricity is passed through them. Reactivity and trends in the periodic table. This is a major topic for the periodic table. If you are considering to understand the periodic table, you need to know what are the trends of periodic table. Trends, what do you mean by the trends? Yes, so there are basically the trends in periodic table which makes the elements to assign their position in the periodic tables. These trends are the repeating patterns which are found in the modern periodic table as you move across a period or down the group. These are the patterns which are being continuously being repeated again and again in order to ensure what are the characteristic of particular element and where to assign it, either in the periods or in the group. What is the first trend in the periodic table? It is about the atomic radius. Atomic radius. Now what do you mean by atomic radius or the atomic size? Whenever we draw the structure of atom, as we have already studied that in chemical reaction and equation, and also in the hydrocarbon while we were studying about the covalent bond. So there is a central part which is the nucleus, and then there are the certain energy shells which is being classified as the orbits where the electrons are being revolving around the nucleus, right? Now, as you can see, these are the electrons which are being present at the energy shells. This is the nucleus, right? Now, from the nucleus to the last electronic shell, you can see this. This is considered as the radius of the atom. So the distance between the nucleus to the last electron of an atom is the radius. Now as we go from left to right in the period, what happened in the period, or you can say the horizontal row, the atomic size generally decreases. Okay, now why does it happen so? Because as you know, atomic number is being decreases in the atomic number decreases from left to right. As the atomic number will decrease, the atomic radius will also decrease. But from top to bottom, that is in group. As we go from top to bottom, atomic number is increasing. So as the atomic number increases is directly proportional to what? Atomic size. So in this way the question comes, they can ask you what will happen to the atomic number as you go from top to bottom, what will happen to the atomic size as you go from the left to right, and also they can give you the name of elements which are situated or being placed from left to right, and they can ask the questions according to the elements. So across a period, sodium is smaller than magnesium and then chlorine. Chlorine is the biggest one. Now here also as you go down the group, lithium is higher, sodium is higher, and potassium is smaller. So top to bottom, at the top to bottom it will always increases, and from left to right, since atomic number is basically decreases in the periodic table. So atomic size is directly proportional to the atomic number. In period, atomic number, since it is decreasing, that is why from periods atomic size will also decrease. But from top to bottom, atomic size is being increased due to the atomic number which is being increased. That is why from top to bottom it will increase. Now the second trend is about the ionization energy. What do you mean by ionization energy? Ionization energy is the energy which is required to remove the electron from an atom in the gaseous state. It increases across a period and decreases down the group. Now what will happen, as you can see, atomic number is being increases, right? And it is directly proportional to the atomic size, which is also being increases in the group. So what does happen in ionization energy? So ionization energy is basically, since you can see this is a nucleus and these are the energy shells where all the electrons are present. Now ionization energy is the energy which is required to remove the electron from the outermost shell, right? From the outermost shell. Now what will happen? As you are going to increase the shells, because atomic number is being increased, so atomic radius is also increasing. As you keep on increasing the electronic shells, the radius will get starting bigger, right? From the center of the nucleus to the outermost shell. Now the energy which is required to remove this electron, become more, because the hold of nucleus is less to the last electron shell. यही होगा ना, क्योंकि न्यूक्लियस का अब कोई होल्ड नहीं रहा उसके लास्ट शेल में, वो बहुत छोटा हो जाएगा तो उसका कोई होल्ड नहीं रहेगा, तो इलेक्ट्रॉन जल्दी से जल्दी बाहर निकल जाएगा, राइट? क्योंकि एनर्जी ज़्यादा लगेगी नहीं, देयर आर द शेल्स, क्योंकि ये न्यूक्लियस का ज़्यादा जोर किस पर है? फर्स्ट शेल पे है. सेकंड पे भी हो सकता है, थर्ड पे भी हो सकता है, फोर्थ पे भी, लेकिन अब इतनी लास्ट शेल में तो उसका नहीं रहेगा, उसका होल्ड पकड़ के नहीं रखेगा, तो लास्ट इलेक्ट्रॉन झट से बाहर चला जाएगा। दैट इज़ वाई आयोनाइजेशन एनर्जी अगर आप ग्रुप में जाएंगे तो डिक्रीज हो जाती है, ज़्यादा एनर्जी नहीं लगती है। ज़्यादा एनर्जी कहाँ लगेगी? जहाँ पे होल्ड ज़्यादा होगा, जहाँ पे एटॉमिक नंबर जो है कम रहेगा, जिसके कारण एटॉमिक साइज जो है हमारा छोटा हो जाएगा। एटॉमिक साइज छोटा रहेगा तो जो न्यूक्लियस है उसकी पावर इस इलेक्ट्रॉन पे ज़्यादा होल्ड करने की होगी ना, वो पकड़ के रखेगा। पर आयनाइजेशन एनर्जी भी तो बढ़ जाएगी, एनर्जी बहुत ज़्यादा चाहिए होगी, क्योंकि हमें इलेक्ट्रॉन को इसके न्यूक्लियस की होल्ड से या पकड़ से छुड़वाना है। तो आयनाइजेशन एनर्जी पीरियड्स में ज़्यादा होती है फ्रॉम लेफ़्ट टू राइट, बट वही आयनाइजेशन एनर्जी ग्रुप्स में फ्रॉम टॉप टू बॉटम डिक्रीज हो जाती है, बिकॉज उसका होल्ड इतना नहीं है। Now the third property, that is electron affinity. So electron affinity is termed as electron attraction. So electron affinity is the energy which is released when an electron is added to the neutral atom. It generally increases across a period and decreases down the group. Same thing as that of ionization energy goes with the electron affinity. Affinity is explained as the nucleus attraction or the nucleus hold on the electron which is present at the outermost shell. In the chemistry, you basically understand this concept that whenever we talk about the electron, no, we are talking the electron which is present at the outermost shell. Always remember that every concept of chemistry or major concept of chemistry is on the outermost shell electron. Now we will study about the next trend, that is electronegativity. So we have electronegativity generally talks through or referred to as the tendency of an atom to attract a bonding pair of electron. It increases across a period and decreases down the group. Now what will happen now, as we will start from the atomic number only. Atomic number from left to right is being what? Is being decreased, right? Since it is decreasing, atomic radius is also decreasing. But we have stated that ionization energy is being increased because nucleus hold on the last electron is more, right? So what happens, from left to right, as we go, from the left hand side there are metals, and as we go to the right there are non-metals. So non-metals generally have the property, they have the property, like for example, if we consider chlorine, right? We have studied that non-metals can also consider as liquid and gases. So we have seen that chlorine has the sign of negative sign, right? Why does the chlorine has a negative sign? Do you know? Because chlorine last valence electron is 7. Now it can gain the electron to complete its electronic configuration. But in chemistry, always remember that element which is gaining the electron, which is accepting the electron, gets a negative charge on it. That is why the tendency of an element to gain the electron means it has the higher electronegativity property in them. So non-metals generally have the higher electronegativity. Okay, because they have the tendency to gain the electron and makes their electronic shell or electronic configuration stabilized. But metals do not have that property, so they have the low electronegativity, and generally you can see they have the ion that are positive because they have the tendency to lose the electrons. Okay, because the nucleus hold is very small, right? Nucleus can't hold the last electronic shell, so it can donate it, right? It can lose it, and while losing, the in chemistry element have the positive charge on it. The most eminent trend is about the reactivity, because reactivity, to know about the reactivity of the elements is like crucial part, right? Because we need to handle the elements, so we need to know the reactivity of the elements. So the reactivity of metals refers to how easily they lose electrons and react with other substances. It increases down the group and decreases across a period. Obviously, as you have already know that in non-metal they have the tendency to gain the electrons, and that is why they have the higher electronegativity. But if we talk about the metals, metals have the tendency to lose the electrons, right? So their reactivity is much higher than the non-metals. It increases down the group and decreases across the period. Reactivity of non-metals is less because as we go from left to right, there are the non-metals, and that is why across a period it increases. The reactivity of nonmetals refers to how easily they gain or share electrons. It decreases down a group and increases across a period. These are certain periodic trends as we go from left to right in the period and as we go from top to bottom in the groups. Going to do practice certain questions like this one. Chlorine is found in group 17. Predict whether it is a metal or non-metal. So it is present in the group 17, which is like at the extreme right of the periodic table. That means that chlorine is non-metal. Francium is found at very base of group 1, right? Alkali metal. When would you expect whether it is added to water? When it is added to water, so francium will react explosively, right? It will form the hydroxide ions. Helium is located at the rightmost part of the periodic table. We already know that helium is an inert gas. It is a noble gas, and what can you say about its atomic size? So helium has the smallest atomic size. Fluorine in group 17 is highly reactive. Iodine is found below the fluorine. Make a prediction about the reactivity of iodine. So iodine would be less reactive than the fluorine. I think that's how we have completed the periodic table chapter. We have gone through certain trends which are basically required to assign the elements and to know about their reactivity or certain characteristic and properties of the elements which are present in the periodic table. For this chapter, I am going to meet you in the next class with the next new chapter. If you have any doubts or any confusions, just comment down below. I am going to reply them. Then keep on learning and keep on revising. Bye bye. Take care.